All right, welcome to part two. We are trying to graph 2 secant x over 3, and we know that secant and cosine are reciprocals of each other, so we are going to find the key points of 2 cosine of x over 3. And I went through and I found that these were the points that I'd be interested in. This function is going to be 0 at 3 pi over 2, 9 pi over 2, negative 3 pi over 2, negative 9 pi over 2. This function is maxed out at 2 at these points, and it's minimized at these points at negative 2. Now that I have those points, we want to think about what happens with the reciprocal of this. So basically, any place that the cosine is 0, the reciprocal is undefined. I can't divide by 0. I can't put 1 over 0. I can't have the secant function ever touch 3 pi over 2. Because if secant's 1 over cosine, and this is where cosine is 0, I've got 1 over 0, that's a no-go. So when I'm graphing my secant function, now that I know where the cosine would be hitting that 0 line, I'm going to have these gorgeous vertical asymptotes. Any place that cosine would have been 0. Ooh, this starts to look so frightening. The next thing to figure out is, I'm going to put 1 in here. Usually the cosine's doing something like this in here, right? That's what's happening. Well, let's think about this. Here, at this point, cosine was maxed out at 1, and then that 1 was multiplied by a 2. So it became 2. Its reciprocal, when cosine was 1, its reciprocal is also 1, because the reciprocal of 1 is 1. And that'll also then, therefore, be maxed out at 2. So all these points that we have here, these 2, this 2, this 2, this negative 2, negative 2, they're all going to stay right where they are. They're not going to change at all. As this cosine approaches the place where it's getting 0, in this part, we're getting smaller and smaller and smaller positive numbers. Smaller and smaller positive numbers on this side, smaller and smaller positive numbers on this side. Which means the reciprocal is getting 1 over very tiny positive, 1 over even smaller positive, 1 over even smaller positive. So it's getting larger and larger. So it's going to go ahead and shoot off towards infinity like this, and on the other side also shoot off towards infinity. And all these guys are going to do the same thing. Same thing, same thing. And a similar but opposite argument tells us that that's what's happening down here. I'm going to walk through it, but if I were to continue this little graph, in this little, as I approach this 3 pi over 2 from this side, I've got negative numbers, because the y values are negative, and they're getting smaller and smaller and smaller and smaller and smaller. Negative 0.5, negative 0.2, negative 0.3, negative 0.1. So as they get smaller and smaller and more negative, the reciprocals get even further from 0 and also negative. It's going to look like that. That's my secant function. If I can graph a cosine function, I can definitely graph a secant function. It's almost the same thing, but now we have all this extra fun analysis of like looking at how the reciprocal of 0 is going to be an infinity point and stuff like that. So I hope this makes sense. If you can do the sine and the cosine, you can do the secant. Zeros become asymptotes, and these max points stay exactly where they are. Look back at the first video where I showed you the Desmos video and check it out, and you'll see what I'm talking about. I'm going to do one of cosecant as well, because why not? And if you don't think you need to watch it, don't watch it. But if it's helpful, please. It's going to take me like half an hour to get it done. So I hope somebody watches it.